Next up, let's talk about motion in space. So here we're going to be discussing the links between the position, the velocity, and the acceleration of an object that's moving through space. So suppose that we'll call it S of t is a position function. So two possibilities here. If we're talking about 2 dimensions, then chances are pretty good you would need an x function and a y function for this. Whereas if we were in 3 dimensions, we would need an x of t, a y of t, and a z of t for our 3 component functions. Now, if I were to start differentiating these functions with respect to time, then I could arrive at some other kinds of functions. So a velocity function would be what we get when we take the derivative of a position function. So same technique for taking a derivative of a vector function that we talked about a couple sections ago. Additionally, if I were interested in the speed of this, I would take the magnitude of the vector function. So hopefully this looks kind of familiar, but this is going to be the square root of dx dt, quantity squared, plus dy dt, quantity squared. And if we're in 3 dimensions, we'll see a dz dt in there squared as well. So taking 3 derivatives, squaring them, adding together, and putting under a square root is the same as what we did for our arc length function. So derivative of arc length with respect to time will give you a speed. If we're interested in finding an acceleration, a of t, this would be the derivative of the velocity function, not the speed function. Or we could also refer to it as the second derivative of the position function. So regardless of which one of those we go for, that'll be the acceleration function. Similarly, if we wanted to go the opposite way, given the acceleration function, an initial velocity and an initial position, it is possible to find the velocity function and the position function. So typically what you'll see for that is, if you're interested in finding the velocity function, you would take the integral of the acceleration function. Excuse me, I made a D, I was trying to make an A. That was my mistake. Let me recopy that so that it's a little bit cleaner. Now typically you'll have a plus C that you would need to find at the end of this, but typically what you're going to find is that whatever the initial velocity is will suffice. And that is assuming that v of 0 is equal to this quantity v0. Additionally, if we're interested in finding the position function, we would take the integral of the velocity function, t dt. Well, recopy that so it's a little bit cleaner. So anti-differentiate the velocity function, and then tag on whatever the initial position happens to be. That's not the right notation. This is assuming that s of 0 is equal to the initial position. Alright, so only a couple little train wrecks in there. Hopefully this was able to communicate everything. If you want to go from position to velocity to acceleration, you're differentiating. If you want to go from acceleration to velocity to position, you will be integrating.